I'm going to teach my students how to use the distributive property. And so normally to start the day, I would tell them to have their pencils sharpened, have their math notebooks out, and get their listening ears ready to roll. We would start off with an automaticity, which can range from a quiz or a test, some kind of assessment to get their wheels rolling and make sure that we're all on the right page, and practice fluency in counting and multiplication. So I would go from sixes to 60, and using the finger method, which would be 1 times 6, 2 times 6, 3 times 6, 4 times 6, 5 times 6, 6 times 6, 7 times 6, 8 times 6, 9 times 6, and 10 times 6. I would count backwards as well, going 10, 9, 8, 7, 6, while the students repeat back to me what the answers are. Now, I could also have a variety of problems written on paper, and we can do it that way. And then I would time them. I'd give them 2 minutes for a sprint, and they would have all the questions on them, and they would be doing their work at their desk. At the end of 2 minutes, I would go around and pass the papers around to different students and have them self-correct. So it would be a good peer teaching strategy that they could use to self-correct and have their peers correct their work. So then after that, I would go ahead and write on the board. I do what's called setting the stage. So usually it's some kind of a word problem, and I would display it and read it all out. And the following problem would be: use the 5 plus something break apart and distribute strategy to solve 6 times 8. Model with a tape diagram. So we had learned previously about a tape diagram, and so I would have them show their skills using the RDW process, and they hopefully would all get it correct because I taught it so well the time before. So they would use a tape diagram, 8 times 6. They would have 6 boxes with the value of 8 inside, and they would break it down. They would break down a let me get a pen. They would break it down like so. Works. Here we go. 2, 3, 4, 5, 6. Value of 8 inside the boxes like so. And then they would break it down like that. So this would be 1 times 8, and this would be 5 times 8. Right? And then at the bottom, they would break down the problem, distributive, like so. And then they would solve underneath. Like so. Hopefully that's not backwards and you can see that. So, today we will use the distributive property to help us solve problems. And then I would go into the concept. When we use the break apart and distributive strategy, we factor. Which factor do we break apart? We break apart the number of groups. Do you think our strategy would work if we broke apart the size of the groups and distributed the factor representing the number of groups instead? Think about the commutative property. Talk to your partner. I'm not sure. I don't think so. The commutative property says that you can switch factors around in multiplication, so maybe it would work. Let's try using the break apart strategy. Let's try using the break apart and distributive strategy. That way, to solve 6 times 8. Then we can compare what happens with our work on the application problem. Take a look at my array. So I would display an array on the board. It would have 6 rows down of dots, and then 8 rows across with dots. So it would look something like this. 4, 5, 6, 7, 8. And I always tell them to make sure that we label our dots, because they can get confusing if we are sloppy. 4. So while I'm doing it, they would be doing it as well, although I would have them pre-prepared. But so my array would look like so. And then on the sides here, I have them labeled, so that way I know I have 6 and 8. So I would say, let's use the break apart and distributive strategy that way to solve 6 times 8. Then we can compare what happens with our work in the application problem. Take a look at my array. Display a 6 by 8 array shown by me. Which factor will break apart the 8, the size of the groups? Breaking it into 5 plus something helps us make 2 smaller facts. We can break 8 into 5 and what? 5 and 3. Write 6 times in the parentheses 5 plus 3. So I would do 6 times 5 plus 3 under the array. So like that. Right? Then, is 8 represented by the number of columns or the number of rows in the array? The columns. How should I draw my line to show that we broke apart the columns? Maybe an up and down line? You could make a vertical line after the 5 columns. Then one part would show 5 columns and the other would show 3. So, draw a dotted line after the 5th column. So, I would count 1, 2, 3, 4, 5. And I would draw my dotted line straight down. So now, underneath, I have my dotted line and I have my equation, right? So, then I would, on my board, write the multiplication facts I would use to label each part of the array. 6 times 5 and 6 times 3. Because now I have 6 rows of 5 and then 6 rows of 3. So I would write 6 times 5 on top, and then 6 times 3, like so. Then, what did we break our 6 8s into? 6 5s and 6 3s. Talk to your partner about 6 times 5 plus 3 in parentheses. Show 6 5s and 6 3s. Use the array to help you explain, then solve the problem. What is 6 times 8? Well, they would then count all the arrays if they couldn't do the mental math. They can count the arrays and see how many dots there are. And that's also when I tell them to label them, because if you miscount, you're not going to get the right answer. So if you have to count the dots, you should label all the dots. And if they counted correctly, they would get 48. Then I would say, look back at your work on the application problem, compare it with the way of solving. Notice what is the same or different. Talk to your partner about what you see. We switched around the factors that we broke apart and distributed. In the application problem, the units never changed. There were always 8s. The one we just had to do 2 different units, 5s and 3s. But what stayed the same was the number of 5s and the number of 3s. So, does the break apart and distributive strategy work both ways? Yes, it does. Then I would go and do another strategy. I would do 7 times 8, and so that way we can bang home the process and make sure that everything was good and that they were understanding the strategy and not just know what 6 times 8 is. Then I would take it into the division. So after I was done with the multiplication, I would have a big chart, and I would be doing it in front of the classroom, and on this chart I would display my multiplication, what I showed you on those note cards, and I would leave it there for my students to look back on when later on in the week, if they needed to look back on the distributive property for our tests or quizzes, and make sure that they just had a refresher and a reminder that it was there. So after that, I'm going to do division. So I would say let's do the break apart distributive strategy to solve 64 divided by 8. So I draw a number bond with 64 divided by 8 as the whole. Leave the parts empty, allow for time for students to draw. So what I would do is I would draw my number bond, 64 divided by 8. Alright? Then I'd have my number bond here. Okay, so let's think about how to break apart 64 into 2 numbers that are easier for us to divide. Make a list with your partner. Remember that when we break apart 64, both numbers need to be divisible by 8. Because we originally distributed the 8 in our application problem. How about 60 and 4? No, you can't divide those by 8. Maybe 32 and 32, or 40 and 24. Using 32 and 32 works nicely because it's a double. 40 and 24 also works well. 40 divided by 8 makes 5. 5 is easy to add. So let's try 40 and 24. So write 40 divided by 8 as one of the parts on your number bonds. So I would go ahead and do that, and in the meantime the students would be doing the same in their writing, in their math notebook. So what division facts then go inside the other circle? Well, so what I would have them do is, since we got 40 divided by 8, I would say, why don't you subtract, because it has to be 64, it has to equal 64, 40 and the other number. The divisible number, the one that stays the same, is always 8. So I'd have them add to 8. And then I would say, okay, go ahead and subtract 64 minus 40, and they would come up with 24. So then they could put 24 in that box. So now we have 64 divided by 8, and then in our number bonds we have 40 divided by 8 and 24 divided by 8. So how do you know 40 plus 24? Write the division facts as the other part. Our number bond shows us that 64 divided by 8 has the same value as combining 40 divided by 8. and 24 divided by 8. Work with your partner to write an addition sentence on your board. Students write 64 divided by 8 equals, in parentheses, 40 divided by 8 plus 24 divided by 8. Work with your partner to solve. What is 64 divided by 8? So you do 40 divided by 8, which is 5, plus 3 equals 8. And that is what our answer is. 64 divided by 8 equals 8. And then I would do another division problem, and they would go ahead and, instead of working with partners, they would do it on their own. And then we would go into the problem set, which I would have on their desks ready to go. And basically what that is a worksheet so that we can go and reinforce the strategies that I just taught them. On this particular page, there is it won't flip. Okay, so there's 8 times 8, and then the same strategies that I introduced and how to break them apart would be what's on this page. And then they have an exit ticket after their problem set is done, and this is usually something graded that I can see if all my students are doing a good job, if they need a little extra help, who can I use in my class to help me teach some of the students maybe that aren't getting it. And then, of course, the additional practice, which goes into their folders so they can take it home for homework. And I'll usually send out some kind of an email if it's a new unit to the parents, to just let them know that, this is what we're going over, and there's no surprises, that the students will have homework every day except for Friday. And that's my mini lesson.